Okay, so this is kind of the final stretch, really. I mean, we're almost there. We've we've almost gone through our laundry list here of items that we need, and most importantly, we got across the ones that were the hardest ones, probably that we had to deal with, which was the presentation stimuli. That required some work, and the flow of events and response collection. So we really have, the bulk of the experiment already in place, at least its primary ingredients. All we then really have to do is just sort of assemble them together and piece it, just piece the parts in order to get to the full thing actually functioning. So what is it that we're missing? We're still missing, our ability of logging responses, of logging results. So what does it mean to log results? It basically means that at the end of each trial, we want to store some information. That might be information, for example, on the trial number that we ran, or, for example, most importantly, the stimulus duration that we presented. So remember that on every trial, the duration of direct gaze is actually going to vary. But we have to keep track on every trial, what was the duration that was actually presented on that given trial, on the 5th trial, on the 10th trial, on the 20th trial. And we also have to keep track of what was the response that the subject gave at the end of that trial. This is important because obviously when we present very short durations, we expect one type of response. When we present very long durations, we might expect another type of response. So we really have to keep track of both these things. Okay, so let's go to our log results section here. Okay, so the key over here is basically exploiting indexing, which is something we came across already a couple of times in MATLAB, which, if you remember, it involves adding, so basically plugging data into a variable or requesting and pulling it out from a variable by basically specifying a location within that variable. Okay, once again, this is all things that you're going to clearly learn if you try out the MATLAB for Psychologists lesson, which I'll actually just include as extra material in here, so you don't even have to look it up online. Okay, so as usual, we have a script that already contains all the things we want, which is logDataTest.m, which is this script over here. But we're going to be, writing our own things just so we actually work at one thing at a time. So let's go 1 second to our test display image, because test display image is kind of the script that we worked on, which most closely resembles what will actually happen. Oh no, actually that would be test flow trial, because we also included trial loops, right? So this is actually the script, which is a little bit, we can start considering this a little bit like the template of our experiment, because it actually contains most of the stuff. I mean, we have all the graphics going on here. We load the stimuli and transform them into textures, and we have trials that are repeating. And in every trial, we're displaying some stimuli. We're waiting for a response, and then we're looping until all the trials have been collected. So obviously, I mean, some things are missing. For example, we might want to include our inputs, for example, the prompts that our participants are going to produce, maybe somewhere at the beginning. So right when the experiment starts, the first thing that happens is that there's going to be a prompt asking the participant to indicate their name, gender, and age. We also talked about displaying text. Text is something that, for example, we could include somewhere in here. For example, there could be text at the once the second stimulus disappears, the third stimulus disappears, which is this one here. When after the downward gaze stimulus disappears, for example, and we're requesting the response, we could actually include some text here saying, respond A if you think that the duration of the upward gaze stimulus was too short, or press L if you think it was too long. So that's something we could include over here, in this line over here. But we have the ingredients, because when we have our test display text, we know how to draw text. It's just this function here, and we know that we have to flip it. Well, the only thing we would have to do is just modify what's actually written in here. So we have the ingredients. The other things we have to do is, of course, control what actual keys are being pressed and make sure it's either A or L. So here there's just a wait command, but we've worked in a separate script. You know, we specifically dealt with this problem. So all this material here, all this code here, could easily be just, you know, plugged in to this area here. Instead of just having this keyboard weight, we're going to have this far more, let's say, you know, far more complex code, but that enables us to have greater control over what's happening with the keyboard. So now we're talking about the logging of data. So basically what we're meaning is that on every trial, we want to store two pieces of information. We want to keep track of them, which is the amount of time that this stimulus was on the screen. Okay, and if you remember, the amount of time that's staying on the screen is random. It's a random number that we're picking. Here it is, rand time. It's a random number. It's a random integer that goes from 1 to 3. So it could be 1 or 2 or 3. On every trial, it might vary amongst those between those three numbers. It's going to wait for that amount of time. But you know, we want to keep track of it, because what's going to happen is that if I'm on trial 1, so I'm at the first iteration of this, I get here, so my program reaches line 41, it draws a random number, and it stores it in rand time, and that's fine. Let's pretend that that number is 3. It's 3 seconds. So it waits for 3 seconds, and then I respond, and now I loop back, because now I'm going to be at trial number 2. So it presents a new stimulus. Once again, it presents the downward gaze stimulus, and then when it comes to drawing the upward gaze stimulus, it's going to pick up another random number, right? It might be 2 this time, but if I just keep on going, what's going to happen is that I'm going to have no trace that the previous time in trial number 1, this number was 3. It wasn't 2. So I have to make sure that I'm able to, at the end of the experiment, know exactly on trial 1, 2, 3, etc., what was the value of rand time. So I have to store this somewhere. Okay? So this is where vectors come into play. So if you remember, we talked about scalars, which is a type of variable in which you simply have, it's just like a box. So you just have a variable and you plug something in it, and it's just one item inside this variable. So A is 1. But I can also have a vector in which typically the syntax when you're assigning values to it would be with square brackets, and you can assign, you know, anything you want like that. And now you have various items that are stored in here, and each item is stored in a specific location. So in location 1, I'm storing 1. In location 2, I'm storing 2. Again, let's not get confused on location and the contents. They might be two different things. So I might have like you know, 99, 100. Right? In location 1, I'm storing 99. In location 2, I'm storing 100. So this is how you plug things into, when you're creating a vector, this is how you create a vector. If I want to use indexing, as we saw, we can actually pull things out of a vector. So for example, I might ask, okay, I want B, but I don't want all B. If I just press enter, I'm going to get all the contents of B. I just want whatever is in the second location of B. And if I use a round bracket for that. So what's in the second coordinate, what second location of B? It's 100. Okay? So the other thing I can do is, so I'm using in this case indexing to pull out a content of B. So B currently has 2 items, and I'm pulling something out. One of its by using this bracket and specifying what is the location I'm interested in. The other thing I can use indexing for is to place new things into B. So for example, I might say to B that I want to add something to B. So currently B only has 99 and 100, but if I wanted to add another number to it, I could add it after 100. So for example, I could say B3. So at the third location, which currently doesn't exist, add something else. So I could add 101. So all of a sudden, as you can see, B has 3 items in it, and the last one is, the last one being the one that's in location number 3, happens to be 101. This is basically what we're going to be doing to store information. So basically, on every trial, we're choosing a random time. The only thing we have to make sure is that now we're storing it somewhere, so we can store it inside a vector. So we could create a vector. Now I could do it in here. I could do it directly in here, but again, we want to isolate the problems here, right? This script is about is primarily concerned with visual stimuli, with just displaying, with loading and displaying visual stimuli. So I don't want to insert stuff that isn't related to that problem. So we're just gonna have a little script which sort of simulates what's going in here, but without all the graphic stuff, because we don't want to, because it's, again, that's not the purpose of the script. So this script, I'm just going to call it something like, we can call it test log. I'm going to be both logging and saving data at separate moments. So I'm going to call it test log and save. Okay. So let's start simulating what's going on in our experiment. So this is all stuff that we're not really going to need. I'm still going to use a try catch, why not? Or let me think. Yeah, because we're going to at least, yeah, I'm going to use a try and catch. So try catch, oops. So I'm just going to actually copy this stuff over here. So I'm just copying this last line, psych throw error, because remember that in the catch, our safety net, in case something fails in this first part, is about closing the screen. And this line here was about tell us what is wrong. So display in the command window what went wrong. Now, we would need to close a screen if we open a screen. In this example here, when I'm working about logging data, I'm not really going to even open a screen because I don't really care about displaying stimuli. So I just want to make sure that if there's a crash, at least I know why it happened, but I don't care about closing a window that I've never opened. Okay, so we're going to simulate basically what's in a trial. And in a trial, what do you have? You have we're going to choose a random time, okay, and we're going to wait for a response, and we're going to see what the response is, and we're going to log both. We're going to log the time that was presented, and we're going to log the response that was produced. Okay, because this is happening across various trials, I'm going to add a for loop. So I'm just going to copy the for bit here, and I'm going to place it here. I'm going to close the for loop already. Okay, so I'm sort of simulating what's going to happen in the trial, and I'm just going to let's say draw a random time. Okay, so I'm just going to draw as in select random time. So let's look for that random time. Okay, so this is what we're looking for. Okay, draw a random time. Very well. So we're sort of pretending here that there was a first stimulus. Now there's going to be a stimulus that going to have a variable duration, so that's going to be presented here. And this is going to, and after this amount of time has elapsed, I'm going to request a keyboard press. So we're not presenting a stimulus, so actually let's do something else, just so we know that we have to press the button. So I'm just going to make sure that once these 3 seconds, or whatever, 1 or 2 or 3 seconds are over, I provide some feedback saying press a key or something. So I'm going to say like instruct to press key. So what we could do, for example, is we could clear the command window just so we end up always with the clean slate on the command window, and then we're just going to display something on the screen, on the command window, and we're going to write down something like press a key. All right. And let's be specific. Press the A or L key. Okay, because we want to be specific about this. We want to log specifically which one of the two was pressed. All right, so then we wait for a response. So where's our response in our script? Over here? We had it over here. Okay, so we could do this. We could just copy this, but actually, since we have a script like this, maybe we could directly put this line, or do we make it too complicated? yeah, let's simplify things, because again, this is very complex, and we're definitely going to use this in the experiment. Okay, yeah. So I'm probably just going to grab these two lines over here. Okay, so just read keyboard and get key that was pressed. Okay, so we're not being too picky about what button is pressed. So I'm actually going to revert and just say press a key. So that's fine for this example. Okay, I'm going to indent. Oops, I think yeah, that's right. I'm going to indent here. So I'm going to select it, Control I, or just, you know, tab button, whatever. All right, and what I'm going to do is, so we're recording the keyboard presses, and I'm finding what key was pressed. Okay, and let's actually identify at least the key in terms of, like, for example, if it was an A or an L. We're not going to constrain it, but we're going to at least identify it. So let's just say, you know, if, so let's say identify key pressed. Okay, so if key, so this is all things that we have over here. If key is equal to 65, all that stuff there, but we're going to keep it simpler. If key is equal to 65, let's just say that our response, let's create a variable called response, okay? And let's say it is 0. So basically, if you're pressing key number 65, which corresponds to the A key on your keyboard, the participant, what does the participant mean by that? So let's just create a code in which 0 means too short. So I'm gonna comment this next to it, just so we understand what this means. Let's arbitrarily decide that a response 0, and I'm going to put this like this, means, what does it mean? It means too short. Okay? So if key is equal to 65, set response to 0, else. If, let's do an else if. Key is equal to, what was it, 76? 76, yeah, 76. So that's the L button. Then response, let's make it is equal to 1. And let's store this here. Let's add this comment here, and let's just make sure that let's arbitrarily decide that response is 1 means too long. All right, then we have to close this. So I'm going to close this if then else statement. And this is why indexing is important, you see, because indentation, sorry, not indexing, indentation. The reason why all this text here is pushed forward, is indented with respect to, for example, this one or this one, is because at some point you start having, for example, things with, so for example, you have a for loop over here, which finishes with an end call, and you have an if statement, if then else statement that finishes with an end as well. If they were on the same level, like this, I could get confused whether this end refers to this or to this, Instead, if everything's pushed, to the correct level of indentation, it's much easier to parse this and understand what's going on. Okay? So let's recap what we're doing. We're simulating trials because we have a trial loop, just like in our experiment. On each trial, we are choosing a duration, for our upward gaze stimulus. Draw a random time. Let's just write it for our up gaze stimulus. Okay. Obviously, we're not presenting the stimulus because that's a graphics issue, and we're using test display image to deal with those problems there. Okay. So we presented this duration. Then at the end of this iteration, you know, we're just making sure that we write something on the screen, on the command window, so the participant, not the participant, this is not an experiment, but so we know that we have to do something after, you know, a variable amount of time. Press a key, and after that we are recording the key, finding what key was pressed in terms of its number. Remember the number within this vector here, and this vector had like 260 or something, I don't remember, entries. And then finally we have a little bit of logic here just to try to determine what was pressed. So if you press 65, the response is 0. If you pressed 76, the response is 1. Oh, let's include, you know, something else, because what if it's neither of those two? You need something else. So else. Response, I'm just going to write, you know, is -1. It just means it's neither of those two. Okay. If I wanted to be consistent, you know, with what I actually would be including in my experiment, I'd probably, you know, just grab all this bit and just plug it in here in place of this. But, you know, again, we want to isolate the problems one at a time. And this specifically, what we're adding in a functionality with respect to what is here, is the fact that here there's no response that's being logged, right? That's the only thing that's missing here. We're missing something to log the response. We're doing these things here, and this is fine because we need to probably also in our experiment we're going to need this to, you know, determine when to stop reading the keyboard. But we're not going to be displaying what key was pressed. We're going to be actually logging here, you know, what response was pressed. We're actually just storing it into a variable, which we call, in this case, resp. Okay, so in resp we have okay, so we have now resp. So at the end of every trial, so and our trial finishes here. So this is where our trial finishes, and then we might loop to a second trial. We have a run time and we have a response, and we want to log them both. So let's log so the time and the response. Okay, so we have to place these two into vectors in order to log them. Okay, so let's call one of them time underscore vector, like that. Okay, so as we saw in the example here, I can plug in, you know, some new data at some given location. So in this case, I plugged some new data at the third location, right? So let's actually pretend, you know, that B is where we want to store some stuff. And let's first of all reinitialize B. I'm just going to empty it. So now B is just an empty matrix. There's nothing inside of it. So let's pretend that I want to store the time on the first trial into B. So how would I do that? I would have to say, like, for example, B1 is equal to some time. I don't know, I'm just going to make this up, 2. Okay, then we're at trial number 2. I would like to add a new value to B. So I want B now to contain the time of the first trial and now of the current trial, which is the second trial. So I could do that by just saying B2 is equal to, I don't know, let's pretend it's 1 second. Okay, and I could keep on doing this. I could then say, okay, on the third trial, let's pretend it's 3. On the fourth trial, let's pretend that it's 1. Okay, so this is kind of the logic of what we're going to be doing. The basic difference is that we're not going to be, because this number that we're using, because the location on which we want to store new data changes on every trial, we can't put a constant, we can't put a number, we can't put a constant number. We have to put a variable. So conveniently, we already have a variable that we can use. So we would need in here, not a constant number. I can't write 1 because or else I'm always going to write at the first location. I can't write 2 because I'm always going to write at the second location, and so forth. I need a number that is going to change on every trial. And what I do already have that variable in here. It's simply called trial. Trial is a variable that at every iteration of this for loop will change its value, will change by 1. So on the first iteration, the first time I'm running this loop, the value of trial will be 1. When it reaches the end, and we start back again, now the value of trial will be 2. And the third time you do this, the value of trial will be 3. We learned this when we started working with for loops, where we sort of did something, we did an example like this, where we sort of created a counter. So instead of calling it trial here, it's actually just called counter. And on every trial, we just did like something with counter. We just did counter times 10. You know, that's kind of what we did. But, you know, I could, instead of multiplying by 10, I'm just going to display counter. And as you can see, on every iteration, the value of counter changes. So all I'm going to write here is just trial. I'm doing the same thing, basically. I'm just using this variable, which is a variable that changes on every iteration of this loop, to index this vector, time vector, and to store something new in it. So what is it that I'm going to store into time vector? I'm going to store the time, the current time, which is runtime. Okay, I'm going to put a semicolon, so I stored it. Okay, so then I'm going to do the same thing with the response. So we can do another vector that's called resp_vector. Again, I'm going to index it in the same way with trial, right? Because again, you know, this is going to be a vector where on every iteration I want to plug something new. So by plugging, I mean this, at a new location. It always has to be a new location. So on the first trial, I want to store the response at the first location of this variable. At trial 2, I want to store the current response on the second location of this vector, and so forth. So I'm just going to do this. Okay, so I'm just plugging the response, whatever it is, on the current trial, 0, 1, or -1, based on what key was pressed, into this vector. Okay, so the last thing I probably want to do is remember that here MATLAB is going to execute these lines sequentially as usual. And there's only one thing that is stopping the script once in a while, which is this instruction here. So the script only stops once in a while because it's waiting for a response from me, right? So until I don't press the keyboard button, the program will hang at line number 17. The problem is that, remember that when I then press this button, the program is going to continue. It's going to loop back up, and it's going to reach this point again. Now, if I haven't released this key yet, it's just going to keep on recording the same button press, and it's going to keep on going. Okay, so I have to add somewhere some other instruction to wait a little bit, just so I manage to have enough time to let go of the keyboard button. So we do something similar in here, where at the end, you know, we had the trial interval. So I'm just going to include this, you know. So we just have a little break. So this is over here. I'm just going to add this here. Okay. So wait at end of trial, intertrial interval, and it's a 1 second delay. So I'm going to save this and run. Okay, so MATLAB, I'm now in my command window where I know that it's busy because it's waiting for me to do something. And as a matter of fact, we have here written press a key. So I'm going to press a key. I'm going to press A. So as you see, A disappeared because we cleared the command window, and now it keeps on saying press a key. So I'm going to press now L. Okay. Now it's saying press the key. I'm going to press something else. I'm going to press spacebar. Okay. Remember, there was 3 trials. So at the end of the third, let's say, iteration, the program exited. So technically, let's pretend that this was our experiment. Our participant finished running their experiment. It was, you know, a certain number of trials. In this case, it was 3 trials. We want to make sure that at the end of the experiment, we know on trial 1, 2, and 3 what were the times and what were the corresponding responses on each one of these trials. And these should be stored into these 2 vectors. So actually, let's look for those vectors. So I'm going to go into my workspace, okay, and I'm going to look for time vector and response vector. Okay, so I have a vector here called time vector, and it contains 3 numbers. Okay, I have another one that's called response vector, and it contains 3 numbers as well. So time vector is, so I'm going to double click on it just so you can see it in the editor. Basically means that on trial number 1, so on the first iteration of this loop, in which trial was 1, we plugged in a value which was 3. So on the first trial, the duration of the stimulus was 3 seconds. On the second trial, so on the second iteration of this loop, where trial is no longer 1, now it's 2, and therefore we're plugging something into now location 2, what we plugged was a number which was 3 seconds. So it was again 3 seconds. Okay? That was the duration of the stimulus. And on the third trial, we have 2 seconds. Now, the same thing goes for the responses. You can, if I open a response vector, I can actually see what my responses were. So I pressed 0, meaning too short, because we arbitrarily decided that 0 means too short. I pressed 1 on trial 2 because I pressed the L key, which means too long. We decided that 1 is too long. And on the third trial, just for the heck of it, I pressed another button just to test that we would actually reach this point. And I press spacebar, and as a matter of fact, it says -1, okay, which is our invalid response, so to speak. So that really covers logging the data. I mean, logging just means that it just basically means that you keep track of what things happened and in what order. And this is exactly what these two vectors permit us to do. That's why we're using vectors. If we had used scalars, we would be able to only track what the last thing happened, because on every new instance, on every new trial, we would just be overwriting. With a vector, instead, we're able to plug new information into new locations, okay, into new shelves of these vectors. Okay, so really the last thing we're missing now is to save the data. So what's the point here? That when you're logging, you're not saving. The difference is this, that when logging basically just means that you're plugging your data, you're assigning data to variables which permit you to keep track of things. But to save actually means to permanently store something on your hard drive. Okay, so we have to do that, because, or else what happens is that if I clear the command window, if I type clear, I'm going to lose all this data. Okay, and we don't want that to happen. Or if I shut down MATLAB, or if I shut down my computer, I'm just going to lose that data. So we have to make sure that at the end of the experiment, once we've collected all our data, we save this to the hard drive. So this is something that you would do at the end of the experiment. So where is it that you finish your experiment? Well, technically, this is your trial loop. So this is where all your trials will be collected, are running. On the last iteration of this loop, which in this case is the third iteration, we exit, after this, we exit this loop. So at the end of the third time we repeat this, we go to line 43 and 44, we're here, okay? So this is basically where we would be saving our data. So I'm just gonna write save the data. Okay, so I could save all sorts of data. I could save all the data if I wanted, in the meaning I could save every variable that I created. But I'm just gonna save the, what does that really need to save? I need to save 3 things. 3 very important things. I need to save the participant data, okay, in the actual experiment. ID, like their name. Okay, I need to know who the subject was. I might want to do that. I'm not doing it here, so I'm just going to leave this in parentheses. Not doing it here as there's no subject prompt. The prompt is something we dealt with in the test input. Okay, here we would be saving subject, essentially, the variable called subject, which contains these 3 elements. But because we don't have it here, we don't have any subject going on in here. I'm not going to write it here, but I'm just gonna keep a note of this, because this is definitely something we want to save when it comes to the actual experiments, as we didn't request a subject name. Okay, so we want to save this when it actually comes to the experiments. I'm just a 1. I'm going to put a 1. 2, we want to save the time vector, and 3, we want to save the response vector. Okay. So how do you save data? Save data is something very simple to do in MATLAB. It's just a function called save. So let's see how this works. So I'm going to type help. I'm going to type save. I'm going to actually close this just so we have a little bit of extra room. Help save. And here it says, save workspace variables to file. So basically save whatever workspace variables you have. It could be all of them, or it could be a subsection of them, to a file. Now, the file basically means that you know that when you're saving like a text file, you save as, I don't know, txt or whatever, .doc. In this case, you're going to be saving into a format, a MATLAB format, which is called .mat. Okay, so how does it work? Well, you need to provide it at least a file name. That's the minimum that you have to provide it. So you could, if you just do save and you give a file name, it's going to store in a file called file name all of the variables in your workspace. We could do that, but it's kind of redundant because we would also end up saving like seconds, keys. We're not really doing anything with that key. You know, who cares about those variables? We don't really need to store that. We just want to store three things when we're going to have this one as well, but we don't have it here. Okay, so here is where you can be more specific and say, okay, I want to save this to this file. I'm going to create this file, this output file called file name, and I'm going to store some variables in it. Now, the variables have to be specified as a string. So it means as if they were text. I'm just going to write this down. So we have save. Okay, so we have to give it a file name. Now currently, you know, we can just give it a file name like test output. Okay? So that would be just this file name. And then we would be specifying always within single quotes, because we have to provide strings, the name of the variables in my workspace that I want to save, which is time vector. And the other one was response vector, like that. Okay. So I could just rerun the whole thing, but I'm not going to run the whole thing. I'm just going to execute this single line, okay? Because I already have all the variables. I don't want to rerun it. So I'm just going to go into my command window, okay? And I'm just going to do this. I'm just going to run this line here. Okay, and something happened. Okay, something happened. So this is actually saving a file called test output. So I'm going to go to my current folder tab, and I should look for a file called test output. Test output, there it is. Now, test output contains just the time vector and response vector, okay, that I've saved. Now, in order to actually notice that, what I'm going to do is I'm going to clear my workspace, okay. So now currently there's no variables in my workspace. It's a clean slate, right? So if I type resp vector, I'm going to get an error because there is no resp vector in my workspace. If I load this, so if I double click on this and I go to my workspace, now you can see that there's two vectors, okay. So actually I'm able to save, so now I've logged this data and I've actually saved it. So this is what we're going to probably be using in our experiment as well, sure, definitely. But obviously in our experiment, we're not just going to save it as some random name, because if we just leave test output as the name of the file, we're going to overwrite the data of each subject. So we're probably going to need something which might be, for example, the prompt that participants, when we ask the participant through the text prompt to give them our name, we could use that as the input that we give here. So for example, if let's actually do that just so we sort of incorporate that element of functionality in here. So I'm just going to go to test input. This is where we asked the participant name, right? So I'm not going to really worry about well, yeah, let's just be consistent. I'm going to copy the whole line. Okay, I'm going to grab this and I'm going to move it over here. Subject.name is equal to input your name, okay, and it's a string. So this is where we were asking someone to input their name. We could just use this as the name of our output file. So I'm just going to replace this which is just a generic name with the actual name that I specify here. Okay, so I'm just going to run these two lines. Now, if I copied them like this into the command when I just executed this, because this is an input instruction, it would, and I press enter here, it's actually going to then record enter as my subject name, so I don't want to do that. What I'm going to do is I'm going to just select these two lines, and I'm going to run just these two lines from within the editor. Now, the way you would do that is just by pressing F9. I wanted to see if there was a little shorthand for that, but there's not, apparently. So if I press F9, it's going to, instead of running the whole script, it's just going to run the lines that I've selected. So it's just going to run these two lines. So I'm going to press F9. Okay, so it's asking me for my name. And I'm going to write, I'm going to write something like test output prompt, because it's what I was requested to insert my name through the text prompt, like that. So if I now press enter, and I look in my folder, in my current folder, there is a mat file called test output prompt. So that's exactly what I wanted. This is probably what we're going to be doing in the experiment, because in the experiment at the beginning we're going to be asking this type of information. So we keep track of the subject, the gender, the age. We actually save subject also as a variable, so we would have subject like that. Okay, I'm not going to do it here because I don't have that variable yet, And the other thing we're going to do is we're actually going to use the subject name as the name of the file that we're going to, in which we're going to write the data that we logged. So we pretty much covered all the data logging by simulating sort of what happens in our trials, because this is a trial loop. And we also dealt with saving, which is very, very simple. So let's just go back here. So we talked about logging, yeah. We explained why it's important to log, because you want to store what happened on each single trial. You don't want it to overwrite it. You don't want it to be erased. We used indexing. Indexing was the way through which we managed to plug new data into a vector. We also, covered this already, how to save the data. So it's very, very simple. So it's the fact that if you're logging data, it's not permanently stored on your system, so you have to make sure that you're saving. And when you're saving, you're storing all the variables, or a subset of the variables, the ones that you're actually really interested, into a mat file. Okay, and we gave that mat file a name, and that name happened to be the name that was requested at the beginning through a prompt, through a text prompt. All right, so in the next lesson, we're just going to briefly recap some of the points here, and we're going to actually use all this information to build the experiment, which is something that actually you're going to be doing, but I'm going to provide you with a sort of a blueprint of a script that then can be populated with all the components that you worked on. So I'll see you there.